In 1967, on a humid summer night in Michigan, a brand new GTO idled at a stoplight. The exhaust thumped, the hood shook, and under that sheet metal sat 400 cubic inches of pure defiance. The driver next to it didn't know what was coming. When that light turned green, the GTO disappeared into the night, leaving nothing but noise and tire smoke behind. The Pontiac's taillights shrinking into the darkness. The smell of burning rubber hanging in the air like a warning. Pontiac had just created something wild, something aggressive, something that felt almost illegal. But what almost nobody knows is this. The very thing that made Pontiac's 400 high-compression V8 a legend is the same thing that nearly destroyed it. You think you know this engine? Not like this. By the mid-1960s, the muscle car war was exploding. Chevrolet had the 396 big block rattling windows across suburban America. Ford had the 390 FE and the new 428 Cobra Jet waiting in the wings. Chrysler was sharpening its 440 Magnum and quietly preparing the fire-breathing 426 Hemi for street duty. Horsepower numbers were climbing every single year. Insurance companies were getting nervous, parents were terrified, gearheads were ecstatic, and Pontiac wanted dominance. Complete and total dominance. The original GTO formula had already shocked Detroit in 1964. Nobody expected it. Nobody saw it coming. A mid-sized Tempest with a full-size engine crammed into the engine bay. It was almost reckless, almost rude, and it worked beautifully. But by 1967, the old 389 cubic inch engine was reaching its limits. The bore spacing was fixed from the original design. The block casting had only so much room left to grow. Engineers needed more displacement, more breathing, more compression. They needed something new, so they punched it out. The new 400 cubic inch V8 kept the same 4.12 inch bore as the outgoing 389, but increased the stroke to 3.75 inches. That subtle change in crankshaft throw gave it exactly 400.6 cubic inches of displacement. On paper, it didn't sound revolutionary. Just 11 more cubic inches. Just a fraction more stroke. In reality, it changed everything. But there was a problem. A big one. Pontiac didn't just build a bigger engine, they built a hotter one. Much hotter. The base 400 came with around 335 horsepower in standard 2-barrel trim. Respectable power for the average buyer. Strong enough to embarrass most of the competition. But the real story was hiding in the high output and Ram Air versions. That's where Pontiac engineers stopped playing it safe. Compression ratios climbed to 10.75.1 in the performance variants. In some early 1967 configurations, they were effectively flirting with 11.1 depending on head casting variations and actual combustion chamber volume. That was sky high for pump gas of any era, especially the inconsistent varying octane fuel of the late 1960s. The Ram Air. I-variant officially made 360 horsepower on paper, but insiders knew that number was intentionally conservative. With functional hood scoops feeding cooler, denser outside air directly into the engine, freer-flowing exhaust manifolds reducing back pressure, and aggressive cam timing that kept the valves open longer, real output was closer to 370 or even 380 horsepower. Torque? Over 445 lb-ft of pavement twisting force, enough to twist drive shafts into pretzels, enough to shred bias-ply tires without mercy or warning, enough to make experienced drag racers respect every single launch. And then came the Ram Air 2 in 1968. This wasn't just marketing nonsense. It wasn't a decal package. It was a genuine engineering evolution. The Ram Air 2 featured round port cylinder heads that completely changed airflow characteristics. Larger 2.11-inch intake valves and 1.77-inch exhaust valves moved more mixture in and more exhaust out. Improved port design let the engine breathe at higher RPM without choking. Same 4.12-inch bore, same 3.75-inch stroke, same displacement, but now it revved harder and pulled stronger past 5,500 RPM, right where the original Ram Air I started to fall off. officially rated at 366 horsepower. Unofficially, more like 390 horses ready to run. Quarter-mile times dipped into the low 13-second range in factory trim with street tires and a competent driver. Some well-tuned cars with proper traction broke into the 12s. In 1968, that was serious territory usually reserved for dedicated drag cars. Factory GTOs were running with genuine race machines. At tracks across America, Pontiac drivers were making statements, loud ones. At the 1968 NHRA Winter Nationals in Pomona, privateer GTOs equipped with the 400 Ram Air were posting competitive elapsed times against big block Chevelles and fearsome Mopars running 440s and even Hemis. Street racers on back roads from California to Michigan reported trap speeds pushing 108 to 110 nm in the quarter, and when tuned properly with racing slicks and open headers reducing every ounce of restriction, some cars were cracking 112 mph through the traps. Word spread fast. Pontiac had a monster on its hands, but every hero has a weakness. Every legend has a flaw. High compression is a double-edged sword. Always has been, always will be. It makes more power because it squeezes the air-fuel mixture tighter before ignition. More squeeze means more force when the spark plug fires and the explosion happens. More force means more horsepower pushed down through the rotating assembly. Simple physics, but it also means more heat building inside the combustion chamber. More stress on every component from piston crown to cylinder wall, and far less tolerance for bad fuel, wrong timing, or operator error. And late 1960s pump gas? It wasn't always consistent. Different stations sold different blends. Octane ratings varied by region. Some pumps delivered true premium fuel, others didn't. There was no standardization like we have today. You never quite knew what you were getting. Owners began reporting problems. Pinging under load, spark knock during acceleration, detonation that sounded like marbles rattling around inside the engine bay. Under heavy throttle, especially in hot summer weather, or during sustained highway pulls, the 400 would protest loudly. The engine was telling them something was wrong. Some engines survived the abuse, some didn't. One dealership mechanic in Detroit reportedly told a frustrated customer, "You can't run cheap gas in this thing. It'll eat itself alive from the inside out." He wasn't exaggerating, not even a little. Detonation at 1075.1 compression could spike cylinder pressures violently and unpredictably. Instead of a controlled burn pushing the piston down smoothly, you got an explosion that hammered everything brutally. Bearings took the hit first. Rod bearings would show signs of distress within a few thousand miles of abuse. The copper overlay would wear away. The lead tin coating would show scoring. Some bearings spun entirely, destroying the crankshaft journals and ending the engine's life instantly. In extreme cases, piston tops developed tiny fractures, hairline cracks spreading across the aluminum crowns. Aluminum doesn't forgive shockwaves the way cast iron might. It absorbs damage silently until it fails catastrophically. And then there was the camshaft situation. Pontiac engineers had given the high-compression 400 aggressive cam profiles to maximize high RPM breathing. More duration kept valves open longer. More overlap meant better scavenging at speed. It made glorious top-end power that pinned you to the seat. But at low RPM, manifold vacuum dropped significantly. Idle quality suffered badly. Some engines ran rough in traffic like they were barely staying alive. Cooling systems had to work overtime just to keep temperatures manageable when the car wasn't moving. Air conditioning made everything worse. What they discovered next changed everything about how Pontiac approached these engines. By 1969, Pontiac unleashed the Ram Air 3 and the legendary Ram Air 4 variants. These were the ultimate expressions of what the 400 could become. The Ram Air 4 was the absolute peak of factory high-compression insanity. Still, 400 cubic inches of displacement. Still, 4.12-inch bore by 3.75-inch stroke. Same basic architecture, but now running around 10.75.1 compression with radically improved round port heads featuring exceptional airflow, 1.65.1 ratio rocker arms, increasing valve lift, and a camshaft that was borderline race spec aggressive. The cam alone was something special. It had enough duration and overlap that vacuum-operated accessories struggled at idle. Some Ram Air 4 GTOs had trouble running power brakes smoothly at stoplights because manifold vacuum was so low. Officially rated at 370 horsepower. That number fooled nobody who knew what they were looking at. In reality, many experts and dyno tests estimate 410 or more horsepower in completely stock form. Some estimates run even higher, depending on the specific combination and testing conditions. Torque hovered around 445 lb-ft at lower RPM before the engine wound into its power band. In period road tests by major automotive magazines, Ram Air Rifle GTOs ran the quarter mile in 13.0 seconds flat at nearly 108 miles using factory street tires and conservative launch techniques. With professional tuning, proper tire pressure, and adequate traction from sticky slicks, high 12s were absolutely possible. Some magazine tests cracked 12.5-second passes. These were factory street cars running with the best Detroit had to offer. But here's the part most people don't realize even today. The engine was right on the edge of what the block could physically handle. That 4.12-inch bore left limited cast iron material between adjacent cylinders. The cylinder walls were already thin by design necessity. Overboring beyond 0.030 inches during rebuilds risked thinning the walls dangerously. Push it harder with more displacement, add more RPM stress, and you were gambling with cast iron that was never engineered for sustained 6,000 plus RPM abuse. Oil control was decent under normal circumstances, but not perfect. At sustained high RPM, especially in road racing scenarios with extended corners and lateral G-forces, oil aeration could become a serious issue. The oil would foam, pickup screens would suck air, pressure would drop momentarily. Pontiac's oiling system fed the cam and valve train effectively under straight-line acceleration, but under extreme cornering loads like those experienced at road courses, oil pickup starvation wasn't unheard of. Builders learned to add baffles and improved pickup tubes for serious competition. Drag racers learned quickly what worked and what killed engines. Keep it cool between passes. Keep it fed with premium fuel. Don't over-rev it past the red line thinking you'll find more speed. Respect the engine's limits. At the 1969 NHRA Nationals, several Ram Air or VU-powered Pontiacs made strong qualifying passes that turned heads in the pits. But reliability under repeated stress wasn't guaranteed. A blown head gasket here from excessive heat. A spun bearing there from oil starvation. A cracked piston from one bad tank of fuel. High compression is absolutely unforgiving. It takes what it wants. And then the world changed completely. In 1970, the Clean Air Act loomed over Detroit like a dark cloud. Emissions regulations tightened dramatically. Lead was being phased out of gasoline. Insurance companies were already hammering muscle car owners with massive premiums that made ownership painful. Some 20-year-old drivers were being quoted over $1,000 per year just to insure a GTO. That was more than some basic cars cost brand new just a few years earlier. Fuel quality shifted too, making everything worse. Lower octane unleaded gasoline began creeping into the market, slowly replacing the leaded premium that high compression engines needed desperately. Engines designed for 100 octane premium fuel suddenly had to survive on gasoline barely rated in the low 90s. The numbers didn't work anymore. Pontiac saw the writing on the wall before anyone else wanted to admit it. Compression ratios began to drop. By 1971, the once mighty 400 saw its compression fall to around 8.4.1 in many applications. Nearly 2.5 points of compression ratio gone. Horsepower ratings plummeted on paper, partly due to the industry-wide switch from gross to net ratings, but also because the engines were genuinely detuned for survival. The fire was being put out deliberately, but for a brief, blazing moment between 1967 and 1970, Pontiac's 400 high-compression V8 was one of the hottest small-block displacement engines anywhere in America. It wasn't a big-block brute like the Chevrolet 454, with massive displacement doing the work. It wasn't a hemispherical monster like Chrysler's 426 Hemi, with exotic engineering and a fearsome reputation. It was something different entirely. It was balanced aggression. It had a relatively short 3.75-inch stroke, which meant it revved cleaner and faster than many long-stroke rivals gasping for breath at high RPM. The 4.12-inch bore allowed for large valves and strong breathing without port shrouding. With the right heads and cam combination, it could pull hard to 6,000 RPM and beyond without feeling strained or running out of breath. But it demanded respect from everyone who touched the throttle. Owners who ignored octane requirements paid the price quickly. Pistons cracked from detonation forces. Head gaskets failed from excessive pressure and heat. Spark plugs showed peppered white porcelain from lean conditions and detonation damage. Experienced mechanics would pull engines apart after failures and see the damage written clearly in melted aluminum and scored steel. Yet enthusiasts loved it anyway. They loved it because of the risk. Because when it was right, when everything worked perfectly, it was absolute magic. Drop the hammer in a 1969 GTO Judge with a Ram Air Full 400, and the car lunged forward with a deep mechanical roar that came from somewhere primal. The hood-mounted tachometer needle would sweep past 5,000 RPM faster than you could process. The rear end would wiggle and fight for traction. The world outside the windshield would blur into streaks of color, and for those few seconds before you lifted off the gas, nothing else mattered. Not bills, not work, not anything. Just speed, just sound, just the feeling of 400 cubic inches doing exactly what Pontiac built them to do. Production numbers tell another part of this story. In 1969, only around 700 Ram Air Ford GTOs were built total for the entire model year. True high-compression monsters were rare even when they were new on dealer lots. Most buyers couldn't afford the insurance. Most buyers didn't want the rough, idle, and finicky nature. Most buyers chose lesser engines. Today, surviving numbers are far lower than those original production figures. Many were crashed, many were abused, many were parted out when engines failed. Original matching numbers Ram Air 4 cars with documented history can fetch six-figure prices at major collector auctions. Some exceptionally well-documented examples have crossed $150,000 or climbed even higher. Why? Because they represent the peak, the edge, the moment right before the fall. Most people think muscle cars died because they were too slow in the 1970s. They see the low horsepower numbers and assume the cars just got weak. But the truth is more complicated than that simple narrative. They died because they were too extreme for the changing world around them. Too much compression for available fuel. Too much fuel consumption for rising gas prices. Too much political pressure from regulators. Too much insurance cost for young buyers. Everything that made them great also made them impossible to sustain. Pontiac's 400 didn't fade quietly into irrelevance. It was forced to cool down by circumstances beyond anyone's control. Detuned by necessity, civilized by regulation, strangled by economics. But its legend was already written in every time slip, every burnout mark, every story told at car shows decades later. Today, builders still chase that magic formula from 50 years ago. Many modern restorations run forged pistons and slightly reduced compression ratios, around 9.51 or 10.1, to survive on modern pump gas without detonation issues. Some brave builders go even higher with dedicated race fuel for shows and events. Aftermarket aluminum heads fix many of the original detonation issues by improving combustion chamber design, increasing heat dissipation, and allowing for more precise quench distances. but the soul of it remains exactly the same. 4.12 inches of bore, 3.75 inches of stroke, 400 cubic inches of American cast iron ambition. Too hot for its own good? Maybe. But that heat is exactly why we're still talking about it over 50 years later. Pontiac's 400 high-compression V8 didn't just make horsepower numbers to brag about at stoplights. It pushed engineering limits. It flirted constantly with the edge of detonation. It forced owners to understand octane ratings, timing curves, spark advance, and proper tuning. It rewarded those who respected it with performance that still impresses today, and it punished those who didn't with expensive repairs and heartbreak. In the end, that's what made it truly special. It wasn't safe. It wasn't forgiving. It wasn't built for compromise or comfort. It was built for a moment in time when more compression meant more courage, when risk was part of the reward, and when that moment ended, so did the entire era. If you enjoyed this deep dive into Pontiac's hottest small block legend, let me know in the comments what engine you want to see next. Another high compression monster that pushed limits? A forgotten underdog that deserves recognition? Or a rivalry that changed Detroit forever? Make sure you subscribe so you don't miss the next story, because the golden age of muscle wasn't just about speed on paper, it was about risk. It was about pushing boundaries nobody asked them to push, and nobody took bigger risks than Pontiac with their 400.